Question number 23. In the figure below, OA is equal to vector A, OB is equal to vector B, and BX meets OY at C. OX is to OA is equal to ratio 1:2, and BY is to YA is equal to ratio 1:3. Part A, we are told to express in terms of vector A and B, Roman 1, BA. So we are moving from B to A, and the root we are going to use is B to O plus O to A. So B to O, we have negative vector B because you are moving against the arrow, plus OA is vector A, and this can be written as vector A minus vector B. Roman 2, we are expressing in terms of vector A and B, OY. So we have OY, which will be given by the root OB plus BY. That way we will have moved from O to Y via B. So from O to B, that is vector B, plus BY. BY, the ratio of BY is 2, YA is 1:3. So BY will be 1/4 of BA. So 1/4 of BA, and we already have BA in Roman 1 above, so we will have B plus 1/4, and then in the place of BA we replace with A minus B vector. When we open the brackets, we'll have vector B plus 1/4 vector A minus 1/4 vector B. So now we collect the like terms together. We have B minus 1/4 vector B, which is 3/4 vector B plus 1/4 vector A. Now we go to Roman 3, and in Roman 3 we are told to express in terms of vector A and B, BX. So we are moving from B to X, and we'll use the root B to O, O to X. This is B to O plus O to X. B to O is negative vector B plus OX will be 1/2 of OA. From the ratio, we are told that OX is to OA is equals to 1/2. This means that if we want OX of OA, then it will be 1/2 of OA. This is negative vector B plus 1/2 of vector A, which can be written as 1/2 vector A minus vector B. Part B, we are told that given that OC is equals to HOY and BC is equals to K, BX, determine the values of H and K. So we have to express OC in two different ways so that we can compare the two expressions, and that we will be able to find the value of H and K. So OC, the first expression, can be given by H or Y, which is equal to H, and in the place of OY we will have the expression which we obtained in A Roman 2, which is 3 over 4b plus a quarter A (3 over 4 vector B plus a quarter vector A). So we open the brackets and this expression becomes 3 over 4 H vector B plus 1 over 4, which is a quarter, H vector A. That is the first expression of OC, and OC can also be expressed as OB plus BC. OB is vector B, this is B vector, plus BC we are given as K of BX. So we will have vector B plus K into the expression which we obtained for BX in Roman 3, which is a half A minus B. So we have 1 over 2 vector A minus vector B. Then we open the brackets and this will be vector B plus half K vector A minus K vector B. Now we can collect the like terms together. We have B minus K vector B plus half K vector A. We can factor out vector B and this becomes 1 minus K vector B plus half K vector A. This is the second expression for OC, and therefore we can compare it with the first expression of OC. Now if you look at the coefficient of vector A in OC1 should be equal to the coefficient of vector A in OC2, since OC1 is equals to OC2. So the first coefficient of A is a quarter H. So we have 1 over 4 H should be equal to the coefficient of vector A in OC2 is given as 1 over 2K. So 1 over 4 H should be equal to 1 over 2K, and that one is our equation number 1. We also compare the coefficient of vector B, and the coefficient for vector B in OC1 is 3 over 4 H. This means that 3 over 4 H should be equal to the coefficient of vector B in OC2, which is 1 minus K, and this is our equation 2. Now we have equation 1 and equation 2 which are in H and K. Now we are supposed to solve them simultaneously to get the value of H and the value of K. We can make H the subject of the formula in the first expression, which is 1 over 4 H is equals to 1 over 2K. So multiply by 4 and multiply by 4, the value of h will be equal to 2k. Then we substitute this value of k in equation 2. So we have 3 over 4, and in the place of h we'll have 2k is equals to 1 minus k. So if we open the brackets, we'll have by 2 by 2 1. So 3 over 2k is equals to 1 minus k. We collect the like terms together. We'll have 3 over 2k plus k is equals to 1. We can make it linear. We'll have multiplied by 2, we multiply by 2, and we multiply this by 2. We have 3k plus 2k is equals to 2. This means that 3k plus 2k is 5k, which should be equal to 2. So divide by 5, divide by 5, and the value of k is equal to 2 over 5. Now we can get the value of h from this expression, where h is equals to 2k, and we have the value of k as 2 over 5. So h will be equal to 2 multiplied by 2 over 5, which is equal to 4 over 5.